Okay, folks, example number 4, it says solve by the substitution method. Okay. Let's see, this one's looking a little weirder. All right. Let's see. Let's write the two equations. I've got y over 2 is equal to 2 minus x. That's one equation. The next equation is 6x plus 3y is equal to 12. You know, I'm always tempted to go to the variable that doesn't have a coefficient, which means that its coefficient is 1. So I'm looking at negative x here, and I'm thinking, okay, I could add x to both sides to make it positive, right? And that's going to give me x plus, here, let me do that. I'm sorry. Let me do that in red. I like keeping the same color. And just like that, okay? And you know what? Rather than doing that, let's do this. Subtract 2 from both sides. Right? So now I've got y over 2 minus 2 is equal to negative x. Okay. Well, let's multiply this side by negative 1 and multiply this side by negative 1. Because I don't want to know what negative x is. I need to know what x equals. So that's going to give me x on the right side. And when I distribute that negative, it becomes negative y over 2 plus 2. Okay, so this is what x equals. Now, I'm going to take that and I'm going to plug it in for x in the other equation. So now I've got 6 times, not x, but what x equals. Negative y over 2 plus 2 plus 3y is equal to 12. Okay, so when I distribute this in, remember, please know how to multiply whole numbers and fractions. Okay, that's going to give me negative 6y over 2. I'll reduce that in a minute. Plus 12. And then, oh, whoa, where am I going with that line? I'm going to distribute that. Okay, plus 3y is equal to 12. Okay, all right, let's see what happens. So now, negative 6y over 2 is the same as negative 3y plus 12 plus 3y is equal to 12. Whoa, okay, all right. Where is this going? Let me combine the two 3y's here, the negative 3y and the positive 3y, and they just cancel out, and that leaves me with 12 equals 12. Okay, well, what does that answer mean? Well, you remember last night when you were graphing, occasionally you'll get two equations with coincidental graphs. That means their graphs coincide. One's right on top of the other. They have infinite common solutions. That's what this means. That means it doesn't matter what you plug in for x and y. They're going to be the same solutions for each one of them. Okay? So when I get something like this, which is always true, that means infinite solutions. Their graphs have the same slope and the same y-intercept. One graph lays right on top of the other. When that's a true statement, I get infinite solutions. Remember the last one, I got a false statement, like 16 and equals 6. Well, that's not true. That means no solutions. But when I get something like 12 equals 12, that means infinite solutions. All right. I think you're ready for your homework. Get started.